7:05. We're going to give everyone a minute to join the Zoom. We are working with Hunter test number 2. We are doing the math section today only. So if you have that, make sure you have it out in front of you. Make sure you have your notebooks and your pens and pencils, because we are going to be taking notes on all of the questions. So if you have questions on any of them, we're going over every single one in detail today. So you can look along. Someone
Yes,
asked.
and I want to just take a moment to remind everyone, record. No, we're not going to record the meeting. We have it on record anyway, so we're going to email to you if you need. I just want to let you guys know if there's anything, you can type questions in the chat. So let me see, maybe I'll see Kate, for example. Kate, can you just type in the chat? I just want to make sure that we're doing that without any issues. So please, Kate, if you could just type hello in the chat. I just want to let you know that all of you are welcome to type into this chat. Okay? Good. Please make sure that you type into the chat, okay? Okay.
I think
Perfect. I see it. We see it. All right, we can keep going.
Okay. Let me just send a link to the exam.
We also sent you guys an email, a text message, so you can have that as well.
I'll also just send it really quickly in the Zoom to everyone. So at the individuals that were asking for the Zoom link, I just sent it in the chat. Chloe, we are going over the entire exam together today. So you can, if you haven't done it, just do it along with us.
Yeah, oh, I just want to, we did reading yesterday, so today's math. You know that, right, Carolina? We're going to go over math.
We're only doing math today. Yes, Oliver, what's your question?
Our goal, wait, just type it in the chat, okay?
Yeah, just type everything in the chat. I'm going to get started in 1 minute. So I'm going to clear this. This is what the first page of the math section looks like. So everyone should open up to that page on the test. Do we need any materials for the test? Aside from a pencil, I don't anticipate you guys needing any other material. You are not allowed to have any calculators. This is the exam that we're going over today, so for everyone. Oh wait, that is. Okay, we're gonna get started. We're gonna review concepts and the test problems, okay? So 51, what is the value of the expressions? I gave you guys the wrong one. 1 second, let me find the exam. Hunter College High School exam. I have the PDF. Can I send a PDF in here?
Oh, do you want me to send it to everyone? I can do that right now.
Also quickly.
I'll send it to everyone. It's not a problem. Okay, let me do it, everyone. I'll send it to you because I actually just sent a text message to everyone. So I sent a text message out. Everyone, if you have any questions, you can type questions into the chat box, okay?
Okay, Hunter lists this one as test 2 and Kweller calls it test number 1. So we just need this test. So for now, everyone, just look on the screen because I'm displaying the exam. So that's what we're gonna do. We're not gonna waste any more time, okay? So I'm gonna be talking to you guys, but I also want you guys to communicate in the chat, okay? So number 51, what is the value of the expression? An expression is a mathematical sentence, essentially, that does not have an equal sign. So the expression that we're looking at is 7 minus 1 times 0 plus 3 divided by 3. What is the most important thing that we have to know about that in this problem? That is the math term. PEMDAS, good job, Stefan. Order of operations, exactly, right? So PEMDAS is a mnemonic that we use to understand what is the order of the mathematical operations that we are going to be applying today. So as we all know, the P stands for what, everyone? Parentheses, good. The E stands for exponents, great job. And then it gets a little interesting here where M and D go, obviously, multiplication or division, and we do the one that comes from the left first, right? And then similarly for A and S, we have addition and subtraction. And again, we do what comes first from left to right. So given PEMDAS and order of operations, what do we do first here? Do we do 7 minus 1, 1 times 0, 0 plus 3? We do 1 times 0 first. Good job, everyone. So we do 1 times 0. Anything, any number times 0 will always be what? 0, exactly. So that means that 7, good job, guys. 1 times 0 is 0. So basically that just becomes 7 minus 0. But as we know, 0 we can just exclude at that point. So we're left with 7 plus 3 divided by 3. Okay, who wants to tell us what goes next? Ooh, yep, I see. Everyone's saying division goes next. Good job. We do 3 divided by 3, which everyone knows that anything divided by itself will always give you 1. Exactly. So 7 plus 1 is where we go next. And everyone knows that the last step here is addition, and 7 plus 1 equals 8. Good job, everyone. So the answer is E, 8. I saw someone earlier mention that they got the answer to be 6. Be really careful. The answer is not 6. If you follow order of operations correctly, like we did together, then we get 8. Where did I get the addition sign from? Right here. Right there. Don't we subtract after? Well, we are not subtracting in this case because, why are we not subtracting? Because we did multiplication instead. 7 minus 0 is still 7, Matthew. Someone asked to send the notes. We are recording this, so you guys can always access this recording, but I'll also save it and I'll try to email if anyone understands and if anyone has questions. Okay, 51 is good. Everyone got choice.
You want to do that?
Sorry?
They can take a screenshot at each one.
Oh, yeah.
Okay.
You guys can take a screenshot. So I'll hold it on for like 10 more seconds. Try to take a screenshot or a picture with your phones if you need.
And then Carolina, I just want to remind you, the kids are spoiled and used to colors. So let's give them some good colors.
I'll add colors. Okay, moving on in 3, 2, 1. I'm going to clear the screen just so it makes it easier for us. 52 is our next question. Of all fractions with a denominator of 17 and a whole number numerator.
Carolina, can you make the questions larger? Can you zoom them out? One of the students is asking. I just want you to know we're all monitoring the chat box. So whatever questions you have, we are checking the chat and we are responding.
That's the best I can do right now.
Okay, if 52. You can plus it more, go ahead.
Okay. Of all fractions with a denominator of 17 and a whole number numerator, how many are between 1/3 and 2/3? Well, I'm going to actually go into a blank screen for this one because I want everyone to understand what everything means in this question. So we are looking for fractions with a denominator of 17 and a whole number numerator. Who can tell me in a fraction, does the denominator go in the upper or lower value? Which one is it? It's the lower one, right? So let's change to red. Our value of our fraction will always have 17 in the bottom and a whole number in the numerator. The numerator goes on top. Now, who can tell me what's special about a whole number? Whole numbers have no decimals, right? It's a whole value. So it can be 1, 2, 3, 4, or -1, -2, -3, -4, but it cannot include any decimals. Okay, so continuing on. They want to know how many are in between 1/3 and 2/3. Well, this gets a little tricky because we are dealing with two different sets of denominators. We have 3 in one denominator and 17 in another denominator. What would be the easiest thing to do here? We would find common denominators, right? Convert the two fractions, 1/3 and 2/3, to have a denominator of 51. Or in this case, we can actually also just transform it into a denominator with 17. And why are we not going to do 51 and why are we going to do 17? Because that's going to make our lives easier, because that way we can actually count how many whole numbers. So I'm going to go ahead and get right into it. Let's start by converting 1/3 into a denominator with 17. Well, I obviously don't know what my numerator will be. I have to find it. How are we going to find what my unknown variable here is? We are going to cross multiply, right? And a lot of you are getting straight to it. The way we cross multiply is we literally multiply like diagonally across. Think of an X. So first thing we do is 1 times 17, and that's equal to 17. And the other side of our equal sign is going to be 3 times x, which we know is 3x. Now, again, I'm only looking for my unknown variable, which is x in this case. So I would divide by 3 to get rid of that 3 that's attached to the x. So what do I get? I get that x is equal to 17 over 3. And this is an improper fraction, right? What would 17 over 3 be as a mixed number? 5 2/3. Good job, guys. 5 2/3. And what would that be as, say, a decimal? Everyone knows that 2/3 exactly is 0.66. So this value is 5.66. So this 1/3 is actually kind of like 5.66 over 17. And we're going to leave our answer like that for now, because we're going to find now what 2/3 is. So we can do this one of two ways. We can cross multiply with 2/3 and then find x over 17 again. Or what do you notice? 2/3 is how many times more than 1/3? 2 times more, right? Good job, guys. So if we know that the value was 17 over 3, well, if we multiply 17 over 3, and everyone knows how to multiply fractions, right? You just multiply straight across in your numerators and straight across in your denominators. We get 34 over 3. So 34 over 3 is what value? 11 1/3 exactly. And what would that be as a decimal? 11.33. Beautifully, beautifully done, guys. So we are looking now at 5.66 over 17, which is representative of 1/3, and 11.33 over 17, which is representative of 2/3. Now, we want to know how many whole number numerators are in between 5.66 and 11.33. Well, let's just list them all out. The next whole number from 5.66 is 6, followed by 7, followed by 8, followed by 9, followed by 10, and we end with 11. So how many whole numbers is that? 1, 2, 3, 4, 5, 6. So our answer is 6. That means that 6 over 17 is in between 1/3 and 2/3. 7 over 17 is in between 1/3 and 2/3. 8 over 17 is in between 1/3 and 2/3, all the way up until 11 over 17. So 6, 7, 8, 9, 10, and 11 are all representative of numerators, whole number numerators that work in this question. I will try to make the font thicker, okay? Okay, so I'm saving this on my end, and I'm giving everyone a chance to take a screenshot, okay? 10 seconds to take a screenshot, and let me know. I'm monitoring the chat, so let me know if you guys have any questions as we're doing these, okay?
Yeah, and we also just want to remind you that there are 2 real release Hunter exams. We have, what I'll do is I'll put this exam again into the chat so everyone has it. And then we are also going to remind you that we have a different set of recorded videos that have Hunter exam release test number 1. This is test number 2. So on the Hunter website, there are 2 exams. This is test number 2, and there's also test number 1. I'm going to put test 2 into the chat right now.
Okay, Nadia asked, why did we multiply 17 times 2? Well, Nadia, we were converting 1/3 and 2/3 common fractions into their respective fractions with a denominator of 17. Now, what do you notice? Right here, which I'm starring in yellow, we converted 1/3 into a fraction with 17 in the denominator. And that is why someone asked why we cross-multiplied. We cross-multiplied in order to find what the unknown variable x, which is our numerator, would be. Now, Nadia, what do you notice? 1/3 and 2/3. 2/3 is just 2 times more, right? So all we got to do to get from 1/3 to 2/3 is multiply by 2. So instead of doing extra work, we saved ourselves some time by noticing that, well, if 17 over 3 is representative of the numerator, well, our numerator is just going to be 2 times that value, right? So that's why we multiplied by 2. Okay, I'm moving on to the next question. 53. What is 15% of the sum 3.5 plus 7 over 4 plus 0.75? Now, I think the most confusing part about this question is just that we are given values both in fractions and in decimals. I personally converted every value here into a decimal because I like to deal with decimals in these types of situations much easier, especially because they are all decimals that are very easy to deal with. So everyone, what is 3.5 as a decimal? 3.5, good job. What about 7 over 4? Well, that's the same thing as a mixed fraction as 1 3/4, correct, guys? So 1.75, good. And what do we notice? 0.75 is already in a decimal. So what do I do now? I simply just add up the values. 1.75 plus 0.75 Well, that gives me 5 plus 5 is 10. I carry the 1. 7 plus 7 is 14 plus 1 is 5. Carry the 1, and I get 2 there. And now I just add on the final 3.5. And like what we all should get is 6.00. Someone said 7. Okay, well now the thing is 6 is not our answer. We need to find the value that represents 15% of 6. Well, what do you guys know? 15% is representative of a value that's 15 over 100, correct? Because percentages are always out of 100. Similarly to like when you have a test, right? You get a score out of 100. So the easiest way to find this value in this case, 15% of 6, is just to do 0.15 times 6. Now let's do it in blue up here, and we're gonna go over multiplying with decimals for anyone that may have forgotten. So 0.15 times 6. We always multiply going from right to left, right? So first things first, we're going to do 5 times 6, which is 30. I carry my 3 over. 1 times 6 is 6, but I add on 3, so that's 9. And 0 times 6 is 0. Now, all I got to do now is carry my decimal place over 2 units to the left. 1, 2. So 15% of 6 is 0.9. And I saw that a lot of you were getting that in the chat. So good job to you guys if you got that. Okay. I saw someone got 0.09. Make sure that you're not messing up your multiplication, okay? It seems like you may have added an extra 0 in that case. Why is 6 when the 0.05 is? I'm not sure what you mean by that question. If you can rephrase it, then I can go over that. Okay. Okay. I'm leaving this up for 5 more seconds, and then we're moving on to the next question. Zero, what's your question about the 0.09? Timmy, the answer to 51 was choice E, 8. Okay, moving on. Moving on to the next page. 54. 54 is one of those harder questions on this test, so everyone please pay attention. At the bottom is a completed addition problem with all the digits replaced by letters. First things first, everyone tell me what digits are. Numbers, but what type of numbers? There are only how many digits? Ayla, you're really close. Who said it? Sophia S. You are correct. You were the first one to say that there are 10 digits. The only digits we have are 0 through 9. Now, it is important to notice that digits are single number values and they are whole numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 are the only digits that we have, okay? They are whole numbers, but they are a specific type of whole number. Moving on. Every letter represents a single digit, and different letters represent different digits, which means that if H is 1, M cannot be 1 again. which digit might the letter T represent? So I'm going to switch to the whiteboard so we're given more space. The question we are dealing with is MH plus MH plus MH. When you add all of those values up, you get TM. In this question, we have to do just different types of scenarios, okay? So I'm going to try to color each scenario differently. How do we add? We always add starting with the rightmost column, right? Well, let's see. If we assign H to be 1, the smallest possible digit, then what would M be? M would be the sum of 1 plus 1 plus 1, right? So good job, guys. M would be 3. Well, in that case, what would T have to be? What would that value be? We would basically just be adding 3 plus 3 plus 3. 9. Okay, guys, perfect. 9. But is 9 an answer choice option for us? Well, A is 2, B is 3, C is 4, D is 5, and E is 6. No. So while T could be 9, that means that there are other scenarios that also work with other values, and we just have to figure out what those values are. So moving on, let's say that H would be, what would be the next best guess? 2, right? Good job. So if H is 2, what would M be? Well, again, we're adding up the rightmost column. 2 plus 2 plus 2 is 6. Good job, guys. So in that case, if M would be 6, what would T be? Well, 6 plus 6 plus 6 is 18. But what do we know? All these numbers have to be digits. Is 18 a digit? No, 18 is a number. So this won't work either. So on to the next scenario. 3. Where are we starting next, guys? 3. Good. H is equal to 3, which means in this case, M would be equal to 9, such that T would be equal to 9 plus 9 plus 9, 27. Does this work either? Nope. So what's next? We keep going. 4. Okay, guys, you already know what I'm going to ask next. What's the value for M in this case? 12. Can we even continue? Yes, we can continue. Yes, we can. Let's go over that really quickly. 4 plus 4 plus 4 would give us 12, and we would just carry over the 1. Okay?
Carolina, can you check the chat really fast? I just sent you a message. I just want to see if that's a yes or no. Just because we're doing well with time.
I have so many messages.
The last one I just sent.
Can you send it again? I have so many messages. Okay.
Guys, we're going over Hunter test number 2. I just want to let you know. And I'm sending Carolina, just check the chat box. Just scroll all the way down, okay?
I am, yeah. Good job, Blessing. So M would be 2 and not 12. Yeah, Francis, I can definitely try to if time allows.
Okay, so everyone, I just want to give you an update. So that's definitely a yes. Carolina, are we good?
I do have to end at 9, but if we have time, then we'll try.
Okay, so everyone, we're going to go through as many questions as we can. How many more do we have in this test?
About 20 something.
Okay, so we're going to go through 20 more questions, and then we're also, as a bonus, going to go through Hunter Test 1 math. Hopefully time will allow, so we'll get extra juice hopefully out of this time. So let's keep going through every question. I'm also going to link a video that you can watch outside of class that has Hunter Test 1. just because the links seem to have been confused between test 1 and 2, but we're going to put both so that you have it. All right, Carolina, let's keep going.
Okay, guys, so pay special attention to this one because I see where you guys are getting confused. How is M2 but not 12? Well, keep in mind that M is the digit in the ones place, right? You guys all are familiar with ones place, tens place, hundreds place, right? M is the value in the ones place. We just carried over the 1 from the, sorry, losing my train of thought. We carried over the 1 from the tens place of the 12 value, but M is still 2. So it still remains 2 plus 2 plus 2, and we add that additional 1 that we carried over. So good job, Ayla. The answer would not be 5. In this case, the answer would be what? What would our T value be? 7. Good job, Molly. Good job, Lucky. 7. So is 7 an option on our test packet? No, it isn't, right? So what do we know? We got to keep going. This is why I said this one takes a little bit more time because you kind of have to test out the possibilities. 5. What's our H value that we're going to try with now? 5. Good job. So what would our M value be? Let's pay extra close attention. 5, 5, 5. Our M value would not be 15. The sum of the values is 15, but our M value is 5. Why can't I just stop here and not even continue anymore? Shy, it's only digits 0 through 9 because those are the only digits that we have. Digits are only values 0 through 9. Shiloh, amazing. Can't be the same digit. What did we remember? That every letter represents a single digit and different letters represent different digits. So we can stop here. Each variable represents something else. Exactly. So where are we going to move on to? We are going to move on to H being 6. Good job, brevity. Such that our M value would be 8. Good, because 6 plus 6 plus 6 is 18. We carry the 1, and our M value is now 8. Well, what's 8 plus 8 plus 8 plus 1? 8 plus 8 is 16, plus 1 is 24, plus 1 is 25. Why does this not work? Because 25 is not a digit. Good. Keep going. Choice or scenario 7, where H is 7. Making our M value become what? M is not 21. Be super careful. M is 1. Good, because what's 7 plus 7 plus 7? 21. Carry the 2. So M is now 1. Well, what's 1 plus 1 plus 1 plus 2? 5. Is 5 a possible value on our answer choices for T? So we found our answer choice. Good job, guys. T is equal to 5. We have a winner. We have a winner. Does this make sense to you guys now? Are you understanding that it's really, really, really important that you pay attention to what the ones value of our M is, right? M represents the ones value of the sum of H plus H plus H. I like that thumbs up. How did you choose the digits for H and M? Well, we chose them for H just going from 1, right? We did 1, we did 2, we did 3, we did 4. But then for M, we just get whatever value it is. Gabby, we can try. Yep. Okay, 5 seconds, everyone. Does this take a lot of time? Yes, but this is one of those questions where you have to apply a little bit more time. but questions like 51 shouldn't take you as much time, right? Okay, I'm taking this down in 3, 2, 1. Okay, moving on. 55. An operation on two real numbers is defined by the rule. It looks a little funky here, but that should be a lowercase a and then a big A, b, equals b to the power of a plus 2ab. Compute 2 symbol, parentheses 1 symbol 3. Order of operations state that where do we start? We start at the parentheses. So where are we going to start? Right here. 1 symbol 3. So the way this works, guys, is that basically this 1 represents our lowercase a and our 3 represents our lowercase b. So why are those letters and what are these weird symbols? Basically, it's just telling you that you are going to apply this rule. So wherever you see a lowercase a, you're going to substitute 1 in this case. Wherever you see a lowercase b, you're going to substitute 3. So what do we get? We get 3, because that's our b, to the first power plus 2 times 1 times 3, right? Because we're following this set of rules right there. Well, what's 3 to the first power? Anything to the first power is just itself, so that's 3 plus, and then what's 2 times 1 times 3? 6, good job. So that value becomes 3 plus 6 is 9. So now I'm going to switch to red. Now we're dealing with a new scenario where this switched to 9. So now we're dealing with 2 symbol 9. And we're going to follow the same rule. We are going to plug in 2 for anywhere where we see a lowercase a and 9 where we follow the lowercase b. What's the symbol after the word rule? I don't know. Oh, right here. This is a lowercase a. It just misprinted weirdly. Yeah. If you guys ever have a question like that, just always ask your tutor, okay? Your tutor will tell you. And then this symbol is just our rule. So again, everyone, help me out. What am I going to change this into? I'm translating it into this set of rules. My b will become my 9, right? A will become my 2. And then again, 2 times 2 times 9, because that is what the rule says. You're confused. Why did we change the value from 1 to 2 and 3 to 9? Because, brevity, look over here. We had a set of rules within a bigger set of rules. And through PEMDAS, we understand that we have to do the parentheses first. So we did the parentheses first, and now we're on to the bigger thing. Okay, what's 9 squared, everyone? You guys should know your squares up until 15. 81, perfect. And what's 2 times 2 times 9? Everyone should know that that value is 36. Good job. 9 times 4. What's 81 plus 36? 117. Good job. So your answer is B. Okay, guys. Leaving it out for a couple more seconds, and then we're going to have to move on. Compute means that you have to find the value. So when you compute a value, you find a value. You basically just do the work. Can we elaborate on the steps? Yes. Okay, guys. I'm going to elaborate, but I'm going to delete all of this. Is it okay if I take it off for now? Take a picture, and then we're going to go into a white screen so I can elaborate a little better. Exactly, Fahiro, if I said your name right. Perfect. Okay. So you guys are going to come across questions like these in the future or on the Hunter exam or wherever, where they tell you, let like say symbol A star B, mean that you actually do something along, say, the lines of 3 times A, B. And then they'll give you a set of numbers. They'll say, find the value of, say, 6 star 7. All they mean is that the value before the star is your A value. So 6 is essentially our A value. And basically the value behind our star is our B value. So all you do is you substitute 6 for anywhere where you say A. Star is just a symbol. So whenever you see that, that's what you would do in the case that that's what they tell you. And we would substitute 7 for wherever we see B. So in this case, we would basically substitute into this expression such that A becomes 6 and B becomes 7. So given this rule that I just made up, 6 star 7 is the same thing as 3 times 6 times 7, because this is our rule. And what is that value? Exactly. We are substituting values for variables. Exactly, Isaiah. What's 3 times 6 times 7? Well, everyone knows that 6 times 7, good. So that value is 126. Good job. Does this make more sense while I explained it using another example? Okay, I'm happy that that makes more sense. Okay, so basically, as someone said earlier, you're substituting values for your symbols, for your variables. Okay, we're gonna move on to 56. When all of the whole numbers between 100 and 350 are written down, how many times does the digit 4 appear? Well, what are some strategies that you guys used? I'll mention my strategy. Well, I first started off by noticing how many times the digit 4 is listed from 100 through 199, because that value would be the same for 200 through 299, right? So first, all the 4s in the 40s zone, exactly, right? So 140 through 149, how many 4s are displayed in there?
Carolina, someone's asking, Elena, how did you know that A equals -1 and B equals 3? Where did you get that from?
We found the value using
Can you
the
just
operation.
elaborate on that? She just put a message into the chat. How did you know that A equals 1 and B equals 3?
So as I mentioned, and you guys have to pay attention, PEMDAS, the first operation, so guys, we're back to 55 for a quick sec. PEMDAS tells you that you deal with the parentheses first. So where were we looking first? We are looking right here, where we are dealing with 1x3. As I mentioned, the value before, as elaborated right here, right? A is your 1 is your A value and 3 is your B value. And you substitute these values for A and B in your rule. Okay? I'm going to leave it at that. But once you get this value, this gives you some kind of number, right? This spits out a number, which we knew was 9. You essentially substitute all of this with 9, such that now you're dealing with 2x9. Okay? What is the big A? The big A is just this symbol. Okay? It's a printing error. Okay. Back to 56. I liked what I was seeing in the chat. You guys started off with noticing how many 4s were in the 140 through 149 range. Someone says 10, someone says 11. Which is it? It's 11, right? Because we got 140, 141, 142, 143. What happens at 144? We got 2 4s. 146, 147, I forgot 145, 148, 149. Good, 11. Okay, and then what about the other values, such as 104 through 194, right? How many 4s are there? Good. I know your name is not Ksenia, but I forget what your name is. We don't want to count the 4s that we already counted. So we're just going to count 104, 114, 124, 134, not counting 144, 154, 164, 174, 184, 194. How many do we get? 9. So together, that's 20 values in the 100 to 199 range, which means that in the 200 to 299 range, we have another set of 20, right? So far we're at 40. But can we count 20 for 300 to 350? Yes, Isaiah, we're basically skipping count by tens. Good, because we're only dealing with 300 through 350. Thank you, Fahiro. Yes, sorry. Okay, so we have 340 through 349, which similarly will have 11 4s. And then what else do we have? We have 304, 314, 324, and 334, which is an additional 4. So there's 15 4s in the 300 to 350 range. 40 plus 15, good job, Mohammed, is 55. This is not that hard of a question. And if you couldn't figure out a quicker method, all you had to do was just list it out, okay? If that was the worst case scenario, all you had to do was list out the values and then simply just count them. Okay, moving on in 5, 4, 3, 2, 1. 57 is another harder question on this test. So I want everyone to pay special attention. Mike, a boy, and Kate, a girl, are siblings. Mike has as many brothers as sisters. Kate has twice as many brothers as sisters. How many girls, counting the children only, are in the family? The way I did this question was I set up 2 different types of equations. So let's start off with Mike. Mike has as many sisters. So let me just write this a little different. Oops, sorry. Mike has as many sisters as brothers. Okay, I'm abbreviating S for sister and B for brother. So this is very, very important to note here. Does Mike consider himself as his own brother? No. Okay, guys, so this is really important. We're gonna label B as all the brothers in the family and S as all the sisters. So B for the boys, S for the girls. But what's important is that Mike does not count himself as a brother, right? Because he's the one that has the same amount as brothers as sisters. So when we do this equation, we know that, well, if we take the amount of brothers in the family and subtract 1, that represents the value of the sisters in the family. Are we all good on that? Okay. So then Katie has 2 times the amount of brothers than sisters. So now we need an equation for her. Well, the amount of brothers she has is 2 times the amount of sisters she has. But what do we know? She's not her own sister, right? So this is the equation we come up with. 2 times the amount of sisters she has, which is the entire family sisters, right? Just minus 1. That equals to the amount of brothers in the family, right? Or the boys. So we have 2 unknown variables here, B and S. What do we do when we have 2 unknown variables? We can substitute for one of them. Do you guys see here how S is equal to B minus 1? So I'm going to plug in B minus 1 for S over here. Why minus 1, Thomas asks? Because we don't count ourselves, right? I have 1 brother and 1 sister, but there's 2 girls in our family. But I don't count myself as a sister, right? So that's why we subtracted 1. So we're going to rewrite this equation as 2 times B minus 1 minus 1, because we substituted S with B minus 1, and that's equal to B. And what do we notice? We have an equation now with only 1 unknown variable. We now just compute regularly. 2 times B minus 1 minus 1. Well, first things first, I'm going to do negative 1 minus 1, which everyone knows is minus 2. That's equal to B. Good job, Mohammed. Good job, Sophia. And then what do we notice? We have to apply distributive property. So we get 2B minus 4, good job, is equal to B. And then what do? Subtract 2B on both sides, such that negative 4, good job, Hansul, we isolate the variable. Negative 4 is equal to negative B. And everything's negative, so what do? Just divide everything by negative 1 to get 4 equals to the amount of brothers in the family. If B is equal to 4, I can just go back to this equation right here, really simple, and find the amount of girls by doing 4 minus 1. The amount of sisters in the family is 3. Let's go back to the question really quick. How many girls, counting the children only, are in the family? Well, we just found that that value is 3. Not 4 girls, Josephine. There are 4 boys, 4 brothers. How did we get the equation? We came up with it on our own, given the information that the question gave us. Can you elaborate on the steps? Yes. So first things first, we came up with 2 equations. Did we add Katie? We included Katie. Why won't you add Katie as a girl? We did include Katie as a girl. Remember, S represents the value of the amount of sisters in the family. Katie is a sister in the family, right? She's just not her own sister. That's why this question is kind of hard to understand. Okay? So Mike has as many sisters as brothers, but he's not his own brother, right? So that's how we came up with the equation in blue. The 4 boys for Mike or Katie, well, they're in the same family, right? So there's 4 boys. Katie has 4 brothers. Mike has 3 brothers because he is one of the brothers, right? So he can't be his own brother. You can use the bathroom. You don't have to ask me. Okay. Then we came up with the equation in red, given the fact that Katie has 2 times the amount of brothers than sisters. We combined the 2 equations by substituting B minus 1 for S in our second equation. And then we found the value for B. And subsequently, we found the answer for the amount of sisters in the family, which is 3. Okay, guys, we do have to keep this, keep going. So I'm gonna keep moving. Ready? I'm gonna take this down in 3, 2, 1. You guys had enough time to screenshot it. I also took a screenshot if you need it. 58. Alla and Bala together drink 750 milliliters of water. If Alla drinks 50% more than Bala, how much does Alla drink? Okay, so in this case, the question set up very nicely for us because the question is in milliliters and the answers are in milliliters. So there's no unit conversions here. So yay for that. Okay, what's the most important piece of information here? That Alla drinks 50% more than Bala. So how can I represent that? Well, if I know that the amount that Alla and Bala together drink 750, that's one equation, right? A plus B is equal to 750. Is everyone set on that equation? The amount that Alla drinks plus the amount that Bala drinks equals 750. Okay, but Alla drinks 50% more than Bala. Well, if Alla drinks, say, 100%, that means Bala would drink 150%, right? So I need another equation here. And that equation is A is equal to 1.5B. Why is it 1.5B? Well, it's 1.5B because she drinks 50% more. So 0.5 would just be 50% of Bala's value. But she's drinking 50% more, so we have to do 1.5B. And what are we going to do? We're going to substitute 1.5B for our A value right there so that we don't have 2 unknown variables. All we have now is 1 unknown variable, right? Such that 1.5B plus B is equal to 750. Are we good on that? Yes, perfect, awesome. What's 1.5B plus B? That value is 2.5B. And that value is equal to 750. How do I find what my B value is now? I have to divide by 2.5. Awesome job. What's 750 divided by 2.5? Not 30. 300. Good job. B is equal to 300. But is that my answer? No, because that's how much Bala drinks. How much does Alla drink? Alla drinks 1.5 times that amount. So what do I have to do now? 300 times 1.5, which is what? 450 milliliters. That's how much Alla drinks. Choice D. Okay. Leaving it up for 5 seconds. How did we get 2.5B? What's 1.5B plus B? There's an imaginary 1 coefficient there, right? You can do Mason 750 minus 300. That is another possible way. Remember, guys, there are so many different ways to do math problems. We're just displaying one way here, okay? Moving on. Robert has been on the road for 1 hour and 50 minutes. He has been traveling at a constant rate. What does constant rate mean, guys? He's traveling at the same what? The same speed. Good, same speed. So far, he has traveled 1/6 of the way to his destination. He's been traveling for 1 hour and 50 minutes. If he continues at the same rate, he will arrive at his destination at 3:30 p.m. At what time did Robert start? Well, first things first. 1 hour. Sorry, just gotta change my color. 1 hour plus 50 minutes. Let's just convert into minutes only, because when you're dealing with hours and minutes, it's not really super simple, right? Because everyone knows that there's 60 minutes in an hour. Good job, guys. That's 110 minutes. And what's special about this 110 minutes? It's representative of what value of his trip. What percentage? 1/6 of his percentage. Good. So if 110 minutes is only 1/6 of his total trip time, well, how much is his total trip? 110 times 6. Good. Which is 660 minutes, which is how many hours? Good. We just divide by 60. Such that that is 11 hours. So if he ends the trip at 3:30 p.m., what are we looking for? 11 hours before 3:30 p.m., right? What's 11 hours before 3:30 p.m.? Hansul, I like what you did. You converted 3:30 into 24-hour time, which is 15:30. So when you subtract 11, it's very easy. But for those of you that aren't familiar with 24-hour time, it's not too hard, right? Because 11 hours is very close to 12 hours. And 12 hours before 3:30, super easy. That's just 3:30 a.m., right? But we're going to add one more hour because it was only 11. And you guys got 4:30 a.m. or p.m.? a.m., right? Good job, guys. I'm really impressed. You guys did this one really well. Okay, another 5 seconds, and then we're gonna take it down. Okay, I'm taking it down. 60. Let's agree to call a number nice if it's not divisible by either 4 or 9. Matthew, don't send weird messages like that because it kind of clogs my chat, okay? Which of these statements is always true? So what do we have to do for these types of questions? We kind of just have to look at all the answer choices, right? Well, let's start with A. If a nice...
I don't know that one.
Sorry, my Alexa turned on. If a number... If a nice number is multiplied by 5, then the result is nice. What's special about numbers that are multiplied by 5? What's special about the answer? The answer will always... Perfect, guys. You read my mind. The last digit in the ones place will always end in 0 or 5. So someone wrote, wait, I keep forgetting your name, but you wrote that 4 plus 9 is 13, can't be divisible. 4 times 5 equals 20. Well, guys, what's the key thing that the question tells us? The number is not divisible by either 4 or 9. So that means that the nice numbers can't be 4. Fahiro, sorry. Let me write that down for myself so I stop asking you what your name is. The nice value cannot be 4 or 9, right? So it can be 1, it can be 2, it could be 3, it could be 5, it could be 7, it could be 6, it can be 8, but it will not be 4 or 9, right? So the answer is actually A, because it will work for every value that's just not divisible by 4 or 9, because if it's divisible by 4 or 9, then it's not a nice number, right? And what do we know? Any value that ends in a 5 or 0 is divisible by 5. But if it is in the case, say, what's 5 times 4? 20. Well, that wouldn't even be considered because 4 is not a nice number, okay? This is a very technical question where you just have to consider all the possibilities, okay? But I'm not going to waste time throughout the other answer choices and proving that they're not right because A is the correct answer, okay? But if you do 8, which is not nice, hold on. For some reason, I get some of your chats on my iPad. What about 40? Well, how do you get 40? 8 times 5. But 8 is divisible by 4. So we don't do 8. Okay, so 4 multiples of 4 will not work. 37, is 37 a multiple of 4 or 9? No, so that one should work. Okay, moving on to 61 right here. 61's another question where you have to work out the possibilities and the answer choices, right? Numbers v, w, x, and y, and z, so they are variables that have numerical values, are placed on the number line shown below. Which expression has the greatest numerical value? Can I zoom in? Let me try. I can only zoom in so much, guys. Okay, I hope that's better. Let's start by assigning values to all our variables. What's the value for v? That one should be easy. That is -3, right? What about w? In the case of w, we can estimate. We don't have to stress ourselves out. Fahiro, -1.5 will not work because it would have had to been exactly on -1.5. I like -1.7. Let's do that. -1.7. What about x? What do we think x is? Also, for those of you that said -1.8, -1.75, those work too. -0.1, we all agree. Yes, I like that one. What about y? That one's easy. Y has to be 0.5, right? Because it's directly on there. And z is also directly on 1.5. Perfect. Awesome, guys. What do you think we're going to do next? We are going to substitute the numerical values, right? Okay, starting with choice A. X times y. Well, x is -0.1 and y is 0.5. What's the value for -0.1 times 0.5? I'm going to teach you guys a trick. How many decimal places do we have here? Well, 1 for 0.1, 1 for 0.5. So our total answer is going to just move 2 decimal places over, and all we got to do is 1 times 5. So our value will be 0.05. Some of you I saw put 2 zeros, only 0.05, okay? That's our value. Moving on. Good job, Dominic. B. Let me change color. What is B? V divided by X. Well, what are we going to plug in here? -3 divided by -0.1. Well, what's that value? I'm going to use fractions because I like fractions. This is just like -3 divided by -1/10. What's special about dividing with fractions? We have to apply Kentucky Chicken Fried, right? KCF, keep, change, flip. That's -3 times -10/1. So that is +30, right? So that's our answer for choice B. Choice C. What's v squared? Well, what's v? -3? What's -3 squared, guys? Someone said -9. No. When you multiply a negative times a negative, you get a positive. So this one's +9. Okay, guys, what do we notice? So far, who's in the lead? Choice B, right? So it won't be A and it won't be C. Let's look at D and E really quickly. Y plus Z, well, what's 0.5 plus 1.5? 2, right? Too small. 30 is way bigger. What about Z minus W? 1.5 minus -1.75? Well, that's 3.2 positive, right? Because negative, when you subtract the negative, when you subtract the negative, you just add. Someone asked, is 3 squared equal to -3 squared? I'm going to explain that in just a sec. So do we all agree that choice B is the largest value? Good, yes. So +30, choice B is correct. Good. Up here, 3 squared is 9, right? Because that's just 3 times 3. When we have -3 in our parentheses, and that's getting squared, that's -3 times -3. So that's also +9. But what's special if we have -3 squared like this, with no parentheses? This is basically just saying this is negative times 3 times 3. So in this case, it would be -9. Okay, parentheses are super duper important in the math world, okay? They can make or break a question by making it either negative or positive. Can I explain B again? Well, we just substitute our values. -3 divided by -0.1. I personally like to use fractions, so I changed it into fractions. -0.1 as a fraction is just -1/10. That is something you guys should be familiar with, converting easy fractions and easy decimals. But when we're dividing with fractions, we have to apply Kentucky Chicken Fried, right? We have to keep, change, flip. Why is negative times a negative equal a positive? Because that is how math works. Negative numbers times negative numbers equal positive numbers, okay? It's KCF, yeah. It's just the way my math teacher had us remember it was think of KFC. That's why I say the funny thing. Negatives hate each other, so they become positive. Yup, exactly. They cancel each other out. Okay, guys, moving on. 62 is a pretty simple question, so let's get this one done quickly. A magic square is a square where the sum of all entries in any row, column, or diagonal is the same for the same. So that means 2x plus 10 is the same as A, 3x plus 3 is the same as 2x plus 10, so on and so forth. What's the value of A they're asking for? Well, what do you notice? Well, 2x plus 10 must be equal to 3x plus 3, right? Well, if 2x plus 10 is equal to 3x plus 3, I can quickly find what my value is. The value is what for x? Subtract 2x on both sides and then subtract 3. X is 7, right? Well, all you got to do is plug in 7 really easily here. 7 plus 7 is 14, which means A is choice E, 14. That one shouldn't take you too long. This is one of those questions that you should do much quicker. Please explain again. What is, Isaiah seems very shocked. What is important? Every value in this magic square is equivalent because it says that all the sum of the entries in any row, column, or diagonal are the same. So you just pick two values here, set them equal to each other, find what x is, and then you can easily find your A by substituting into any of these values. If you substitute x to be 7 for any of these values, you will get 14, right? 3 times 7. Oh, no, don't quote me on that. 2 times 7, 14. Sorry, any row, column, or diagonal, so they're not all equal. Yes, good, Viv. But what do you notice? X plus 7, that's in the same row, but your answer will still be 14, sorry, yes. X will not be 14, X is 7. If I said 14, I'm sorry. I was thinking of 14. They're a different variable. Okay. Moving on. Mickey prepared 2 gallons of a beverage that contained tea and lemonade in the ratio tea to lemonade is 3 to 1. Guys, what's important here? This is a ratio. So it's 3 parts tea, 1 part lemonade, and how many total parts are there? 4, good. 4 total parts. So that means it's 3/4 tea, 3/4 lemonade, right? Sorry, 1/4 lemonade. Mickey then adds 1/2 gallon of lemonade to the mixture. What was the ratio of tea to lemonade in the new mixture? So even though it's 3 parts tea, we need to convert those parts into gallons, right? So that we're dealing with the same unit. So for the tea, well, if it's 3/4 tea, everyone understands why it's 3 out of 4 tea, right? Well, if we multiply that by the total of 2 gallons, how many total gallons do we start with for the tea? What's 3/4 times 2? 6/4, not 6/8. Remember, guys, we multiply directly across in the numerator and the denominator, which is just 1.5 gallons, right? What about for the lemonade? Well, we start with 1/4 part of 2 gallons. So we start off with 2/4. Good job, which is 0.5 gallons of lemonade. But what do we notice, guys? We are now adding a 1/2 gallon of lemonade, right? So what's the new amount of lemonade that we have? 1 gallon of lemonade, right? So what's the ratio now? Well, the ratio of tea to lemonade, I'm going to switch to red. Tea to lemonade is 1.5 to 1, but we don't like decimals and ratios. So what's the easiest value to multiply both terms in this ratio by to get to a whole number? By 2. Good job, guys. So if we multiply everything by 2, we get 3 to 2, which you guys got. Beautifully done. Good job, guys. 3 to 2. Perfect. Leaving it up for 5 more seconds, and then we're going to move on because we need to move on. Okay. 64 is one of those harder questions, but actually, guys, why are we multiplying by 2 gallons? We are not multiplying by 2 gallons. We are multiplying by 2 to get to a whole number. 1.5 times 2 is 3. 64 seems very hard. It's not. All you have to think about is the difference, okay? Anne's watch runs 2 minutes per hour too slow. Beth's watch runs 1 minute per hour too fast. For example, if both watches were correct at 12 p.m. on a given day, then at 1 p.m., Anne's watch would read 12:58 and Beth's watch would read 1:01 p.m. Quick! What is the difference between 12:58 and 1:01 p.m.? 3 minutes. So for every hour, we have an error of 3 minutes. So
Finley, can you make the screen larger as well, just for this question?
Yeah. So guys, if 2 hours pass, but every single hour, 3 minutes, there's a 3-minute error, then in 2 hours, what would the error be? 6 minutes, and in 3 hours, it would be 9 minutes. Good job, guys. 3-minute error per hour. Well, let's start reading the second part of the question. Anne and Beth set their watches to the correct time at noon on Sunday. The next time they meet, one of the watches was 1 hour ahead of the other. Well, that means that the error in time is now what? The error is 60 minutes. Well, how can we find how many hours went by of errors? All we got to do is 60 divided by 3. Good job, Hansul, and good job, Alexander and Emma. 60 divided by 3 means that there was 20 hours of errors, right? And there was 3 minutes of error every single hour for 20 hours, such that there is now an error of 60 minutes between both watches. Well, if we start at noon on Sunday, what's noon, everybody? Noon is what time? 12 p.m., good. What's 20 hours later? $8 a.m. on a Monday, good. Quick question, guys. Everyone, how many hours are there in a day? 24. So if you really wanted to, you could just do 24 hours later and then subtract 4. Good job, Thomas. Exactly, -4. Good. Are we good on this one? It seemed hard, right? But it's actually not hard at all. Okay. Changing in 5, 4, 3, 2, 1. 65. Another question that seems hard. The notes will be sent to you guys. We'll work something out, okay? So examine the pattern and determine how many more shaded squares than unshaded squares will be in the 100 by 100 square in the sequence shown on the right. I want you guys to really try to identify a relationship between the unshaded and the shaded squares. So this is a 1 by 1 right here, right? 1 by 1. This is a 2 by 2, 3 by 3, 4 by 4. And what helped me was noticing the ratio of the unshaded to the shaded. Let's do different colors to the shaded. Okay, what's the ratio for the 1 by 1? Unshaded to shaded. 1 to 0. Good job, brevity. 1 unshaded to 0 shaded, right? What about for the 2 by 2? It's going to be 1 unshaded to 3 shaded. Good. What about for the 3 by 3? It's going to be 6 unshaded to the 3 shaded. And finally, for the 4 by 4, 6 to 10. Good job. Does anyone see a pattern here? Specifically for the relationship to the unshaded to the shaded? One to 3 is 2. Good, Hansul. What did we notice? We're basically For all the odd values, we're subtracting the number that the box is, right? So if it's a 1 by 1, we're subtracting 1. If it's a 3 by 3, we're subtracting 3. But for all the even numbers, what are we doing? We're adding the nth term, right? So for the 2 by 2, we added 2. For the 4 by 4, we added 4. So 100 by 100 is what, guys? That's even or odd? Even. So what would we do between the relationship of the unshaded to the shaded? We would have 100 more shaded values than unshaded values. So your answer is choice B. There is no actual math that you have to compute for this question. All you have to do is recognize the relationship between the unshaded and the shaded squares. Are we good? Yeah, that's what I like to hear. Okay. Are we moving at a comfortable speed? I'm trying to pick up the pace a little bit more. Okay. 66. This is one of my favorite questions on this test. Lena and 3 of her friends bought just enough food so they could go for a 12-day camping trip. So they bought enough food for 12 days to feed the 4 of them, right? So let's start writing that down. 4 people. And how many meals do you guys eat per day? 3, right? Yeah. So 4 people bring enough food for 12 days and 3 meals per day. So if 4 people bring enough food for 3 days to eat 3 meals per day, how many meals did they bring? Well, 4 people eat 3 meals, so that means we need how many meals a day? 12 meals a day, but for 12 days, 144 meals. Good. And the reason I'm doing this in terms of meals is because you're going to notice it's going to be much easier for us. But what happens? Pete and Jane surprised them by showing up at the start of their trip and asking to join, but they brought no food. By what percentage would the time for the trip shorten if everyone ate their normal daily portions? So the normal daily portions, yes, we are assuming 3 meals a day because they don't give us the normal daily portions, but we are assigning 3 meals a day to be the normal portions. But good job, Emma. Now we're at 6 people because 2 more joined. Well, if 6 people eat 3 meals a day, then how many meals are we going to eat per day? We're going to eat 18 meals per day now, right? Well, so now what do we just have to do to figure out how many days of food do we actually have? What supply do we have? Good job, divide. We're going to do 144 because we brought 144 meals, but we are using up 18 meals per day. So how many days are we going to last? We're going to last 8 days. But 8 is not our answer, right? Because what's important to know? Good, we're losing 4 days, right? 12 minus 8 is 4. Well, how do we find percent error? We always base it out of the original value. Good, so 4 over 12. What's 4 over 12 in simpler fraction form? In simplest form? 1/3. And 1/3 represents what percentage? 33.33%. Or the way they wrote it, 33 1/3. Good job, Ela. That's funny. You're right, because 0.33 repeats forever. Okay. The key word to this question was noticing that there were daily portions. Okay, so that's why we set up. What if they only eat 2 meals per day? Then set it up that way. Okay, I just did 3 meals because that was easiest for me. Francis, for some reason video is on for somebody. We could just deal with that. Okay. 67, moving on. Who here likes chocolate? Do you guys like chocolate? Yeah, me too. Rory also loves chocolate, and he eats a lot of it. In 1 hour, he eats half of any amount of chocolate that he has. His sister Kara, hold on. His sister Kara decides to treat him by giving him a bar of chocolate every hour. How many chocolate bars had Rory eaten at the second hour just before Kara gave him the third chocolate bar? Well, what do we have to do here? Hold on. Let me just... Okay. Never mind. So we're going to set up a kind of chart. So initially, he has how much chocolate? He's given 1 bar, right? But then he eats how much of it? Half of it, right? But eats half. So how much is he left with? He's left with half a bar, right? So I'm going to start circling how much he eats. He ate 1/2 just then. But then in the first hour, what happens? His sister's really nice to him. And she does what? She treats him to another chocolate bar. So now he has 1/2 of the bar plus another full bar. So he has 1.5 bar, but he eats half of 1 1/2. Well, what's 0.5 of 1.5? 3/4. Good job. Good job. So that's going from the first hour to the second hour, right? So how much does he eat in total? 1/2 plus 3/4. Common denominator. 2/4 is equivalent to 1/2, right? 2/4 plus 3/4 is equal to 5/4, and then 1 1/4. If a drawing is easier for you, Vivian, then yeah, good job. So the answer is choice D. Okay, guys? Why is it 1/2 of 1 1/2? Angelina, why? Because look what it says right here. In 1 hour, he eats half of any amount of chocolate that he has. So if at the end of the first hour, he has 1 1/2, he's going to eat half of that 1 1/2. That's how much he has left, right? Okay. Does that make sense, Angelina? Okay. 68 seems like a really daunting question. But it's very important to know that we're dealing with a specific type of triangle here. The 3-dimensional shape in the diagram on the right is a cube. What's special about a cube, everyone? It's made up of what? Equal sides, right angles everywhere, all 6 sides are equal. They are all what? They are all squares, right? What is the degree measure of the angle at point B? The angle formed by AB and BC. So let me zoom in right here, guys. This thicker black line, what is it? What do we call that on a square? You guys see the square right here? And then we have this black line. It's not an angle, it's a diagonal. Good. Do you guys see that diagonal there? You kind of have to imagine it a little bit because it's a 3D object, right? A and B are corners on the same square, and that black line is its diagonal. Well, what about the other square that I'm doing in green? What's special about that diagonal? It's the same as the other diagonal. Because again, what's special about a cube? It's made up of equal squares. What's a diagonal? Is it just a diagonal line? Yeah, so when we have a square, it's the line that connects one corner to another corner, just like that. Well, guys, what are we missing? We're missing this diagonal right here, right? That's what they're asking us for. But again, that bottom square is the same as the square for AB and BC. So what do you guys notice about the diagonals in the black and the red? They're all going to be equal. And what do you guys notice is super duper special about the shape? It's an equilateral triangle. How do we know it's equilateral? Because all the sides are equal, which also means that what? All the angles are equal, right? So what's the measure of every angle in an equilateral triangle? 60 degrees. Good job. So the answer is 60 degrees. That's the angle measurement up here that we're looking for. 60 degrees. Okay, are we good on this one? So not 45? No, because who can tell me what's the sum of all the angles in any given triangle? 180, good job. And we have 3 equal angles. So how do we find each angle in this case? 180 divided by 3. Perfect. Good job, guys. Okay, saving this and moving on to the next. And moving on in 3, 2, 1. Okay. 69. The rectangular floor of a room is 4 feet 6 inches wide and 8 feet and 3 inches long. How many square yards?
Can you make it larger for the kids to see also? And I just want to remind you, this is Hunter test number 2. Okay, go ahead. We also sent you a video to Hunter test 1 review, so you have that as well. All right, go ahead, keep going.
How many square yards of floor covering will be necessary to cover the floor of the room? And they are super kind in mentioning that, a reminder that 1 yard is equivalent to 3 feet and 1 foot is equivalent to 12 inches. What's the first thing we should do in this equation, guys? We have feet, we have inches. They're asking for the answer to be in yards. What should we do? Convert units. Everything to which unit? What do you guys think? Yards. Good. Let's start. 4 feet and 6 inches is the same as how many total feet? 4.5 feet. Beautiful. And we can divide this by 3 feet, because that's how many feet are in 1 yard, to get this. Good job, Muhammad. Good job, Isaiah. Good job, Fahiro. That is 1.5 yards. That's the width. What do we have to convert now? The length. 8 feet and 3 inches converts to how many feet? 8 1/4. Good, because again, guys, there's 12 inches in a foot, and 3/12 is 1/4. Good. So I'm going to write that as 8.25, okay? Feet. And again, we're going to divide by 3, right? Because again, there's 3 feet in a yard, and we want to solve for how many total yards there are. What's 8.25 divided by 3? 2.75. Beautiful. So now I'm just going to draw a little rectangle for you guys to visualize this. We have a 1.5 yard width and a 2.75 yard length. What is the question asking us for? They're asking us to solve for this amount of square yards of floor covering that will be necessary to cover the floor room. So what are they essentially asking us for? In mathematical terms, this is called the area. Good job. And how do we find the area of a rectangle? We multiply the length times the width. Well, what's 2.75 times 1.5, everybody? 4.125 yards squared, right? If we were getting technical, you always square your units in area. And you guys should be comfortable. You guys should be comfortable by knowing that 0.125 as a fraction is 1/8. So your answer is 4 1/8 yards squared. Questions on this one? Beautiful. Moving on in 5, 4, 3, 2, 1. Okay. 70. In the last step in solving a problem, Jerry divided 0.4 instead of multiplying by 0.4, and thus arrived at an answer of 400. If Jerry's calculations were otherwise correct, what was the correct answer to the problem? So what do we have to do? We have to go backwards, right? So what do we have to do here? We have to solve for what that value was. Well, if he divided a certain number by 0.4 and he got an answer of 400, what must have that answer, that value for x have been? How can we solve for what that answer was? Well, all we got to do is 400 times 0.4. I don't like decimals sometimes, so 400 times 4/10, that's the same thing, right? 400
Charlene, I just
times
want to give you a heads up. It's already 8:46 and we need to get through the questions. So if it's okay with everyone, we're going to go a little bit faster just because we need to. Are we up? Do we have 80 questions? Do we have how many? 10
Yeah.
more, correct?
Yeah.
So we're going to go a little bit faster, everyone. So please just bear with us. Make sure that you're super attentive, paying attention, because we need to move faster for these last few so that we finish by 9. Okay? Let's go.
Okay. So everyone should have found that that value was 160. So now what are we going to do with that 160? Well, what did he want to do in the first place? He wanted to multiply by 0.4, right? So what are we going to do? 160 times 0.4, which we should all get what? 64. Okay. Yes, Fahira, you are right. It's 1 minute per problem, so we got to keep it up. Okay? Moving on in 5, 4, 3, 2, 1. Be quick to screenshot, guys, if you don't have time to copy. What fraction of the area of the large rectangle is the area of the shaded region? Okay, what is really significant about this question is that they do not give you any numerical values. But what do you notice? Let's look at this rectangle right here. How much of it is shaded? Half. Okay, that's easy. What about in this rectangle right here? Another half, right? And what about in this rectangle right here? All of it, right? One whole. And finally, in this last one, how much of it is shaded? 1.5 or 3/4. What do you guys think we're going to do with all of these values? Add them up. 1/2 plus 1/2 is 1, plus 1 is 2, plus 3/4 is 2 3/4 out of 4 total rectangles, right? So that's 2.75 out of 4 total rectangles. Well, that's the same thing as if we multiply both by 2, that's the same thing as 5.5 over 8, which is not an option. But what do we notice? If we go to the next common fraction, we get 11 over 16. Okay? Good job, Mohammed. Beautiful work. Okay, guys, you guys need to be very comfortable with converting between fractions. Okay, that's something that's really important on the Hunter exam. Okay, I'm changing in 5, 4, 3, 2, 1. 72 is pretty simple. How many numbers less than 51 are a product of 2 different prime numbers? Quick question, guys. What is a product? It is the answer when we do what? When we multiply. Good. It's the result of multiplication. Well, they also give you 2 reminders that a number is a prime number if it is only divisible by 1 in itself. And they also remind you that 1 is not a prime number. Well, let's start off by listing the prime numbers. And what are we going to do? We're not going to go past a value where 51 divided by 2. What's 51 divided by 2? 25.5. We're not going to go past this value. Why not? Because 2 is the smallest prime number, right? So if we're multiplying that value by 2, that would result in the smallest possible multiple. So we're not going to go past 25.5. So let's start listing off our prime numbers. 2, 3, 5, 7, 11, 13, 17, 19, and 23. Okay, guys? What do you notice? 2 times 23 is what? 46, right? So that means if we multiply 2 by any of these numbers, that value will be equal to or less than 46. So we can multiply 2 by 3, 5, 7, 11, 13, 17, 19, 23. 2 can be multiplied by 6 possible numbers. So far we have 6 possibilities. On to the next smallest. 3 times 5 is 15. That works. 3 times 7 is 21. 3 times 11 is 33. That works. 3 times 13 is 39. That works. 3 times 17, that's 51. Are we going to count 17? No, because 51 is equal to 51. It's not less than. So for 3, how many work? 4. So far we're at 10 numbers that work. And what's the last possible possibility? 5 times 7, right? Which is 35. 5 times 11 doesn't work anymore, right? So how many total possibilities do we have? 11. Okay. Moving on in 5, 4, 3, 2, 1. 73. A wooden block measuring 2 inches by 2 inches by 3 inches. Hold on. That's not an answer choice. You guys are right. Because we miscounted. Hold on. 2 times 3 is one option. 2 times 5, 2 times 7, 2 times 11, 2 times 13, 2 times 17, 2 times 19, 2 times 23. It's not 6, it's 8 possibilities. There we go. So that's 8 plus 4 plus 11 is 13. Thank you, guys. Thank you, thank you, thank you. Okay. Are we good now? Okay. Thanks for pointing that out. Back to 73. A wedge is cut off from each corner of the block at points that are 1 inch away from each corner. So as visualized right here. How many edges does the resulting solid have? Note that the wedges to be discarded are shaded gray and the solid is white. Well, how many edges do we start off with? And do you guys know what edges are? They're the line segments that connect corners. How many edges do we start off with? 1, 2, 3, 4, 5, 6, 7, 8, 9. And back there, there's 10, 11, 12. Guys, this is a 3D image. Okay? So initially we start off with 12. Okay? You guys need to visualize the 3 that you cannot see. Now, but what do we notice? I'm going to clear this and move it over. A lot of those edges disappear.
Carolina, heads up, it's 8:55. So do you want to stop with this question?
We can, the next question we can ask whatever they want to go over. Okay, so.
Okay, but we just have to do a 9 hard
Okay.
stop because I have another.
Yeah, no problem. We gotta count, guys.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now, what do you guys notice? Some of these are gonna repeat on the bottom and on the sides, right? So let's see. This top one right here is gonna repeat on the bottom. So let's label it as blue. How many edges are there? 1, 2, 3, 4, 5, 6. What's 6 times 2? 12. Let's label this one as green. How many edges do we see there? Well, we already counted one of those blues. So 1, 2, 3, 4, 5. And there's another one on the other side, right? 5 times 2 is 10. What's the other one that we're missing? The one in the front, right? 1, 2, 3, 4. 4 times 2 gives us 8. Did we double count? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 12 plus 10 gives us 22. Did we miscount? There should be 28. If you guys count, there should be 28.
Everyone, as Carolina's winding down, let's take a moment to type thank you into the chat box. Sorry if I made you miscount, I'm stressing you out, but we do need to do a stop at 9. So I think we need to pause at this point and just say thank you so much. Actually, Carolina, you're teaching tomorrow, correct?
Yeah, what we can do is we can finish up these 5 if that works for you, Francis.
Yeah, that works fine. So everyone, you know what we'll do? Tomorrow at the very start of the webinar, we will review the remaining 5 questions that we have to do, 6 questions. And this time I'm not going to stress you out to count. Let's give Carolina a huge thank you because at peak we had 180 students and Carolina deserves a huge thank you. And who else deserves a huge thank you?
You guys
I
deserve
do.
a
All
thank you.
right. And who else deserves a huge thank you? The students do. Okay. So we want to just say thank you to everyone, the students, the parents, the kids. We're very appreciative that all of you are here. I owe you guys an apology because apparently my links to Hunter Test 1 and 2, this is not my fault. This is completely Hunter's fault. They didn't label the exams. I mean, they only numbered 2, not 1. So they confused me. So apparently I linked Hunter Test 1 to 2. I just want to let you know that I take no blame in this. They didn't label it clearly for me. With that being said, I am sending everyone the video to Hunter Test 1 that was recorded, pre-recorded with Olga. This one is with Carolina. This is also recorded. We will share this recording. Carolina, you are a rock star. You are a girl boss. Thank you for everything that you do. I just hope that you guys realize there's quite a lot of work behind the scenes that takes place. These webinars do not magically happen. As you know, I am supervising the webinar today after our debacle yesterday. And today we had to start a few minutes late last night. So I have learned to micromanage everything all the time, which I have to say has really been a rough reality. I do want to say, Carolina, thank you so much. Thank you for all of these years that you've been part of Kweller Prep as a student, as a teacher, as a tutor. I'm really, really happy that you're part of this community. Thank you to everyone. Thank you to everyone for being here. This is a very special moment. We had 2 hours of math review. Isn't that amazing? Isn't that so great? You guys realize there's way more than 2 hours going on behind the scenes. I just want to make sure you're all aware of that. Not to guilt you, but just, to create awareness. All right. Thank you, Carolina. Thank you so much for this time and this effort. I just want to remind all of you, Hunter has 2 real released exams. So don't forget, this is test 2. There's also a test 1 on the website. Okay. Carolina, do you want to say anything with your last 10 seconds?
Yeah, guys, go to sleep tonight positive. We're going to work again tomorrow and just keep working really hard until your test on Wednesday, okay? You guys want to go in knowing everything and giving it your all, and you don't want to regret anything. That being said, we'll continue from 73. We'll go over 73 tomorrow again, and then we'll go into essay writing and tips and tricks for that.
Thank you so much for doing this.
Okay, guys, I'll see you guys tomorrow.
Thank you for being your amazing self. We're going to close up, and I have really productive. We did a great job. Okay, and we did fix any of those little Zoom technical difficulties we had yesterday. We did a great job, Carolina. Isn't that amazing?
You did great.
Just a few gray hairs.
We have really smart kids here.
Who wants to see my cute little test prep baby? Who wants to see a cute baby? Ready? Jacob, can you say? Oh my gosh, she's throwing stuff at me. Zoom cannot detect a camera. That's weird. Okay, let me think about this. Wait, I might be able to show. Who wants to see a cute baby? Who wants to see a cute baby?
I do.
Oh my God.
Is there a video for yesterday's seminar? Yes.
I think I'm allergic. Wait, Jacob, come here. Jacob, look. Jacob, come. Jacob. What? The baby ran away, guys. Jacob, come to Kweller. Jacob, look. Jacob, surprise. Really, I don't think it's happening. Sorry, guys. Hold on. Jacob, Goldie. Sorry, I'm trying to entice him with my dog. Nope. He doesn't want to come here. Jacob. Hello. I don't know. My kids don't like being like props for the business. I don't know what to do. Like, don't they understand their like purpose in life? What am I going to do with these children? Jacob. Mika, can you bring Jacob, please? Okay, guys, I'm really going to try it. Mika, die. Jacob, come here. Okay, everyone, I'm here. Do you see me? Hello, children. Oh, no photos, please. Yep. Oh, here we go. Ready? Are you ready to see a cute baby? No, wait, can you stop? Can you stop with the baby? Camera switch.
Hi, Jacob.
He's trying to run away with my phone.
He's running with Francis's phone. Okay, guys, don't forget we're going to go over 73 through 80 tomorrow. And we're going to go over the essay section, okay? Hold on, you're muted, Francis. Don't be daunted by the essay. You're going to do great, okay? We're going to go over how to write it.
Everyone.
Okay.
Entertainment for me. Thank you, everyone. All right, I'm glad we had a moment. Am I muted? Really? Jacob, say bye. Bye. Say bye. Look, Jacob, say bye.
Oh, bye.
Bye.
Oh, bye.
Bye, everyone.
Bye.
See you tomorrow.
Say bye one more time. Say bye. Look, say bye.
Bye.
Okay, guys. Bye, everybody. We made it. Okay. Bye. You're so cute. Look at how cute. Okay, there. We're done. Say bye, Jacob. Bye. Say bye.
Bye.